You ever see a poll that claims to know what an entire country's thinking, and you realize they only talk to like 1,000 people? How on earth do they do that? It seems absolutely impossible, but it's the secret behind so much of the data we see every single day. So let's break it down.
I mean, seriously, it feels like trying to figure out what an entire ocean is like by just looking at a single drop of water. The difference in scale is just so huge, it feels like there has to be some kind of magic trick involved. How can this tiny, tiny sample possibly tell you anything about the whole picture? But here's the thing. It's not magic. It's science. And there's this one brilliant and really powerful idea at the heart of it all that lets researchers see that big picture with incredible accuracy, all by looking at just a tiny little piece of it.
And that powerful idea? It's called sampling. Honestly, the best way to wrap your head around it is to think about making a giant pot of soup. You don't have to eat the entire pot to know if it needs more salts, right? You just need one spoonful.
That single spoonful, and this is key, if you've stirred the pot well, tells you everything you need to know about the entire batch. And believe it or not, research works on the exact same principle. That spoonful is your sample, and the whole pot of soup is the entire group you want to understand. So what is sampling officially? Well, think of it as the art of creating a perfect miniature. You're carefully picking a small, representative group from a much larger one. The whole goal is to make that small group a perfect little mirror image of the big one.
And to really get this, we've got to learn to speak the language. The entire group we want to know about, say all the students in a city, that's called the population. And the small group we actually talk to, that's our sample. Simple as that.
Okay, but here's the million-dollar question. How do you actually get that perfect spoonful? You can't just scoop from the top, right? That wouldn't work. Well, researchers have a kind of map with two very different paths they can follow, and each one has its own rules and its own goals. And check this out. This is basically that map. You can see the road forks right at the beginning into two main directions, probability sampling and non-probability sampling. Let's head down that first path and see where it takes us.
So our first path is all about one thing: fairness. It's called probability sampling, and the core idea here is that every single person in the population gets an equal shot to be heard. This is how you create a truly unbiased picture.
The secret ingredient here is randomness. The researcher isn't just picking their friends or people who are easy to find on the street. Nope. Every single person has a known chance of being picked. This is really the gold standard if you want to make sure your sample is a true reflection of the whole population. And researchers have a whole toolkit for this. Simple random is pretty much what it sounds like. It's like a lottery, just drawing names out of a hat. Stratified sampling is more like making a balanced meal. You divide everyone into groups first to make sure you get a little bit of everything. And then there's cluster sampling, which is all about geography. You might pick a few random schools and talk to everyone there.
You know, let's zoom in on one of these methods for a second because it's actually pretty clever and efficient. It's called systematic sampling, and it's a neat way to get a random group without needing a giant hat.
It's a really simple three-step process. First, you need a list of everybody. Second, you figure out your skip number. So if you want to sample 100 people from a list of 1,000, your skip number is 10. And third, you pick a random person to start with, and then you just select every 10th person on that list. Easy. And boom, this shows it perfectly. Look at that. We start with person number 2, then we skip every third person, so we get 5, then 8, and you just keep going all the way down the list. It's a beautifully simple but really effective way to get a random and representative sample. But okay, what if you're not trying to paint this giant portrait of the entire country? What if you're looking for a very, very specific type of person? Well, that's where our second path comes in, the more targeted approach of non-probability sampling. On this path, the researcher is less like a lottery official and more like a detective on a case. They're not trying to be fair to everybody. They're trying to find specific people, specific clues. This is perfect for when you want to explore a really niche topic, like, say, the experiences of non-working mothers. And the tools for this path are all about precision and, well, convenience. You've got convenience sampling, which is, yep, exactly what it sounds like. You just talk to whoever's around. Purpose of sampling is for when you're looking for that needle in a haystack. Snowball sampling is a personal favorite. You find one person and then they lead you to others, which is perfect for finding hidden groups like tempura vendors. And quota sampling is like a scavenger hunt. You have a list of what you need and you just keep looking until you've filled your quotas. Okay, so we've gone down two completely different roads to gather a sample. But why does it matter? Why should you care which path a researcher chooses? Well, this is the punchline. This is where it all comes together. This table just lays it all out. On one side, you have probability sampling. That's the rigorous, equal chance path for getting a reliable picture of the whole population. On the other side, non-probability sampling. It's faster, it's cheaper, and it's great for exploring specific ideas, but there's a higher risk of bias. It's that classic trade-off, right? Precision versus practicality.
But at the end of the day, no matter which path a researcher takes, the goal is always the same. As the source material puts it so well, you're trying to create a small group that is as similar to the larger population as possible. And this is why this all matters to you. The next time you see a poll in the news, you can ask yourself, how did they get their sample? Was it one of those carefully constructed probability samples, or was it a quick and easy convenience sample? Because the answer to that question tells you everything you need to know about how much you should trust the results. So, the next time a headline is screaming about some new study, you'll know what to do. You'll know to look right past the sensational result and ask the single most important question you can. How did you get your sample? Because now you know that's where the real truth is hiding, and you know exactly how to find it.